We're starting at the finished dot products. Direction angles are just the angles that the vector makes with respect to the three coordinate axes. Alpha is for the x, beta is for the y, gamma is for the z. Which means we can just use the axes as vectors, treat the axes as vectors, and then use the cosine theta equals dot product over product of magnitudes. Cosine of alpha. For the x axis, why don't we just use I hat? Well, I hat is what? 1, 0, 0, right? What happens when you take a vector and dot it with I hat?
Same thing.
You won't get the same thing.
Oh, inverse?
Remember, dot product is going to be a scalar,
Right.
so it can't be the same or inverse or anything like that. And think back to the definition of dot product. Sum of the products, right? But y and z components for I hat is just 0, right? Wouldn't that just be the x component of A? What's the magnitude of I? So that would just be the x component of A divided by its magnitude, right? What is the magnitude here? What's 9 and 16? 25? Yeah. 25 and what's 12 squared, real quick? 25 and 144. What was it? 25 and 144?
169.
Given. What's the square root of 169? 13. Remember, your angles are always going to be between 0 and pi. Since the range of the inverse cosine is 0 to pi, you just take the inverse cosine of both sides. Something happened. What happened? No. Oh, that's how it works. Right there. Okay. Well, similar logic. J hat. It's just 0, 1, 0, right? You take the dot product, you're just going to get the y component. And again, magnitude of J hat is just 1, isn't it? Beta would then be the inverse cosine of 12, 13. Find the cosine of gamma. Use k hat for the z axis, which just gives you the z component. Magnitude of k hat is 1. Gamma would be the inverse cosine of 4/15. And so it makes the direction direction angles very easy to find. You just use I hat for your x, j hat for your y, k hat for your z.
Why are all cosine?
That's the definition of angle between two vectors. Use cosine of theta. At least for right now. There's another relation. Value of k that makes the two vectors u and v orthogonal. What does e and v orthogonal?
Sorry, perpendicular.
Perpendicular, which means what?
Normal.
Which means what?
The dot product is 0.
That's the test. We'll get back to that. If two vectors are perpendicular, what does that mean?
They only intersect
You have it. Yeah, they intersect at what?
at 1 point.
Well, vectors are only ever going to intersect at one point.
No, right.
They form a right angle. Which means the dot product is 0. So that's what we want. V dot v to be 0. Dot product is what? 2 plus 3k minus 8. 3k minus 6 has to be 0. This shouldn't require any work. What's k? K has to be 2. So we can prove straightforward. Oh, dot products are so easy. When a unit vector orthogonal to both u and v, so in one way we can do it right now. We can revisit this once we study the next operation. But right now we don't have it. So just define W to be said vector. It's going to have components x, y, and z. Our goal is to find x, y, and z. Well, what do we know? If W is perpendicular to both u and v, then both have to be 0. Both dot products have to be 0. Well, that's going to give you a system of equations, right? What is u dot w?
Oh,
That has to be 0. What is v dot w?
It's 4x, 3y minus z.
And that has to be 0. There's your system. Oh dear. Think back to your studies of systems, of linear equations. Can that system have a unique solution? Okay. No, it can't. Why? 3 variables and what?
Both of the equations.
How many?
Both of the equations.
There's 2 equations and 3 unknowns. You cannot get a unique solution out of that. Not enough equations. There's 2 possibilities. No solution, in which case the system is said to be inconsistent, or an infinite number of solutions. Right? Remember, there are only 3 possibilities. Inconsistent, meaning no solution, and consistent, meaning there's a solution. Either unique solution or infinitely many. There's no in between. We need to know which one it is. So let's solve it. Again, 2 ways to solve it. I'm not assuming linear algebra, so I'm not going to be using Gauss-Jordan reduction, which is the best way to do it. We're going to be using the method of elimination, which is Gaussian elimination without matrices. Remember, the idea is to eliminate as many of the unknowns as possible. Well, it's going to be very easy to eliminate either x or y. Let's eliminate x. Why not? Multiply the first equation by -2 and then add. -2 times 6 is 12 plus 3. 15y. -2 times -3 is 6 minus 1. And then, of course, that's just going to be 0. 15y minus 5z is 0. Which makes y z over 3. There's some real number z. Z can be anything. Remember what z would be called in this case? It's actually 2 terms for it. It's either your free variable or your parameter. Parameters from linear algebra if you write in parametric form. But it's a free variable, it can be anything it wants. Now we just plug y equals z over 3 into one of the other 2 equations to solve for x. What would be the easiest one? Second one. Get x at 0, which is not correct.
Yes, I think when you're adding the terms to cancel out the x, you made it a -5 instead of a +5.
You're right, that should be a +5. That makes that negative, right? That looks better. X has to be what, 0 to 2? So now just write out the solution set. Set of all order triple, 0, 2, negative 0, 3, z, for any real number z. That's the solution to our system. Now, look what it's asking for, though. Just asking for a unit vector. So we can let z be anything we want except for one value. 0. You don't want the 0 vector. I'm going to do 6 to clear out the fractions. Be what, 3, negative 2, 6? That's the vector. But is that unit? Most definitely not. So if we find the unit vector in the same direction, or opposite direction, doesn't matter, right? You just flip the direction by pi, it's still going to be perpendicular. So I could have let z be negative 6 instead, and it still would have been valid. That's the vector we want. 9 and 4. 13. 13 and 36. Nice. 49. Square root of 49. There's our vector. Right? Or another acceptable answer would be if you just multiply it by -1 to flip the direction. However, those are the only two, once you normalize it and simplify. So when it's saying find a unit vector, you only even get 2 possible solutions. And those solutions are just going to be opposite directions of each other. It was just asking for a vector, and then you have an infinite number of solutions. Good? Questions on the dot product?
So because it's asking for a unit, it wouldn't have a definite solution. If it wasn't, that would be.
Well, there's 2 possible solutions because it's a unit vector, yes. Because no matter what value you choose for z, once you normalize it and fully simplify, you're always going to get either this or the complete opposite direction. And I'll let you verify that on your own by trying a different value for z. This might require a bit more algebra, but you will still get that, or like I said, the opposite direction if you let z be negative. Anything else? All right, that finished up the dot product. Just went 1 minute over whatever. All right, so the next 29 minutes will be for the report sheet. Then 10-minute break after that. All right, so 1:30 Then 2 o'clock we start the cross product. So now I'll just go ahead and pause the recordings. So again, I know it's very difficult getting to your group. And your
Also, too.
yeah. Okay, so the cross product. This is also sometimes called the vector product. And if you notice, the cross product results in a vector. And typically the way that we look at a cross product is as a 3x3 determinant. And so you don't have to memorize that formula. We typically just write it out as a 3x3 matrix and take the determinant. I'll show you how to do that. And so properties. First one is called the anti-commutative property, right? Because it's no longer commutative, order does matter. But actually, if you just flip the order, it just multiplies by minus. So we just call it anti-commutative. Does distributed cross vector addition. Same thing as with the dot product, when you multiply by a scalar. Where you put that scalar doesn't matter. Take the cross product of a vector with the zero vector, it's always the zero vector. And any vector cross itself is the zero vector. This is not really a property, it's more of a definition, but that is called the scalar triple product. Right, but the property itself would be u dot v cross w is u cross v dot w. But we can relate the cross product to the angle between the vectors as well. And the magnitude of the cross product is the product of the magnitudes times sine of the angle between them. Locate vectors u and v, they form adjacent sides of a parallelogram, angles given by the magnitude of the cross product. And if you have a parallelepiped that has adjacent edges u, v, and w, the volume is the absolute value of the triple scalar. And notice by its very nature, with the absolute value, the u, the v, and the w doesn't matter. Right? Because the only thing that's going to change is possibly a minus sign, depending on the order. And you take the absolute value, it goes away anyway. So how you choose your u, v, and w doesn't matter for volume. Yes, and now, one of the worst applications.
Oh my god.
I hate torque. Torque itself is a measure of a tendency of a force to cause a rotation. Torque is technically a vector, but generally speaking, when we're talking about torque, we're referring to its magnitude. So if R is vector with initial point located on the axis of rotation, terminal point located at the point where the force is applied, so think of R as the radius. F is the force being applied, your torque vector is R cross F.
And it's
The easiest way to visualize torque is with a connection torque. The axis of rotation is going to be right on the hinges, right? That's torque. But notice, I push really close to the axis of rotation, requires a much larger force to cause that rotation than further away. So you want to make it easier, you increase your radius. That's why if you ever try to get all the, excuse my French, fucking lug nut, you want as long a wrench as possible. Actually, preferably, just get a mechanical one that's electric. That's your best bet. Otherwise, you want it as long as possible. Theoretically, what happens if I push right on the hinge? Your torque would be infinite. Or your torque would be zero. Sorry, the torque would be zero. The force required to cause rotation would be infinite. Now, you're going to have no tendency of rotation right on the actual axis. But that's the easiest demonstration of torque. Show that A dot A cross C equals 0. Two ways to actually go about this. I'm going to do it the easier way.
Just show A times A squared.
Property 6. The triple scalar. Property 5. Any vector across itself is 0. And then there's a property for dot products. I forget the number. Any vector dotted with the 0 vector is automatically 0. Done. The other method is the pure algebraic method. Which would actually require you to define vectors A and C and then do that. Which is what your worksheet's going to have you do. So for the worksheet, you're going to have to do the pure algebraic. Now I want to show that A cross with B cross C is that. Okay. I'm gonna do this in 3 space. Let's define 3 vectors. It's a lot of messy stuff right here. So define those 3 vectors, A, B, C. What I'm thinking about doing is maybe. For the sake of time, I'll come back to this one, because this one is pretty long. Make sure I can get through some actual calculation ones. So I'll just come back to questions with you now. This one is actually number 3 on the worksheet. But let's do it anyway. Let's take a freebie. Wouldn't it be nice if that was like on the exam instead? I have done that actually. Put an example on the exam to see if you're paying attention to the notes. It was literally word for word the exact same question. Again, we're going to restrict this. No, I'm not. I'm not going to restrict to R3.
I didn't finish.
Yeah, I didn't.
I mean, that was
So go back to the magnitude of A cross B. Isn't that magnitude of A times magnitude of B times sine theta?
Wait, how?
That was one of the properties. So I'm just going to use that. But dot product. The dot product is the magnitude of A times magnitude of B times cosine theta. So we need the magnitude of that squared. But that's a scalar, isn't it? A, B cosine theta is a scalar. Magnitude of a scalar is its absolute value.
Why are we taking the magnitude of A because of
Because A dot B is A, B cosine theta.
property? Oh, I see. Never mind.
Right, we want the magnitude of A dot B.
Yeah, I forgot it wasn't the magnitude of A dot B.
That's only for the cross products. Magnitude is A, B.
A
Sine
dot
theta.
B itself.
But if you take an absolute value and square it, you can just get rid of the absolute values, right? Because when you square negative, it's positive. Right, so it's the same effect. So this is actually the same as this. right? There's an a squared b squared common, right? Factor it out. What are you left with? Sine squared plus cosine squared, right? What's sine squared plus cosine squared? You get a squared times b squared as desired. Maybe for the worksheet, I'll mandate that you actually do it the algebraic way. You have to actually set up your A as a vector, your B as a vector, and calculate the cross products and dot products. And show if this is what you get. Just make it a little different. This is the easy way.
On an exam, would you specify which one?
If I don't, then you can do it any way you want. Generally speaking, as a general rule of thumb, in mathematics, well, I guess in physics as well, the simpler the solution, the more elegant it is, so we prefer the simplest path. Right? What's one of the number one, actually I think it's the number one law of quantum mechanics, is that the electron must be in its lowest energy state, which means number one law of physics is everything must be in its lowest energy state. Take the path of least resistance. That means that simulation should be lazy. Embrace it. Embrace it! Work smart, not hard.
Yeah, we have to make that.
And then the second law of physics is entropy. No, entropy is different. Are you familiar with entropy from thermo?
Not another people.
Entropy is essentially chaos. Right? The idea of entropy is it takes energy to keep things ordered. Right? Given enough time, the universe is going to be, it becomes disordered unless you expend energy to keep it ordered. So think of, you have a vibrating, a pill separator or whatever, right? Vibrate, so you put half of the dish is all red pills, half of the dish is all blue pills. Now turn on the vibrating disc, what's going to happen? They're going to mix in unless you keep.
And
That's entropy in a nutshell. So again, I clean my desk. Entropy is just going to say it's become disordered anyway, so embrace it!
For 4 on the worksheet?
We're not discussing the worksheet.
Oh, but
You can talk to me after class about that, if you want to. So area of a triangle having these vertices.
For the same thing.
Which is not perfect. Well, let's just think in 2 dimensions for right now. We're still dealing with a parallelogram. Or actually, in this case, the triangle, but it's the same idea. So say E, Q, R. But
is there a reason for making it 3-dimensional?
Because it's easier to see in two-dimensional. Trying to draw this backwards. I'm gonna go with what I was originally thinking. Think first of a parallelogram. We know its area. And we don't care about this one. This one's not needed. Just put a sad face there because it's not needed, so it's sad. It has adjacents, it has the sides PQ and PR, right? Let's call those vectors U and V respectively. That's its area, right? Is that now triangle PQR? Is that half the area of the parallelogram formed by PQ and PR? That's how we can do it. That's why I'm only working in 2 dimensions right now. Because the idea is exactly the same if the points are 3-dimensional. Because it's still a 2-dimensional object. Right? It's just now possibly going. So let U be PQ. What's PQ? So what is PQ in component form?
-3 and 2.
No, but that's not supposed to be 1, 2, 3, but whatever. I'm working with it. And 2 minus 1, -1 minus 2. And then 1 minus 3. Or you put it on QP, right? It doesn't matter. Generally, you want to keep the same vertex. Now we want PR in component form. That's V. What is it? Oh, look how nice that is.
Why is the one positive and 2 for the PQ?
2 minus 1.
Because it's 2 minus 1, -1 minus 2, and then 1 minus 3.
So you're subtracting Q from V.
Yes, terminal minus initial. So again, I'll keep it with this. That's actually really nice. Now here's what I can show you how to take the cross product. Since we're taking magnitude in the end, you could do U cross V or V cross U, right? Doesn't matter. All it's going to change is a negative sign. But when you take the magnitude, the direction doesn't matter. And you're just dealing with length, and it's going to have the same length, just possibly opposite directions. So let's just do U cross V. That's why it also doesn't matter how you set it up. PQ, PR, doesn't matter. All right, so for this section, I will write out the determinant. Generally speaking, I can do it in my head. So we're going to set up a 3x3 matrix, and we're taking its determinant, so put the vertical lines around it. First row are your standard unit vectors ijk. Second row is U. You said it was what, 1, -3, -2?
Yeah.
Third row is V, which was what, -2, 0, 0? The method that we're going to use specifically is cofactor expansion. It's called cofactor expansion. And again, specifically across the first row. So what that tells us to do is we're going to take the 1, 1 entry that I had. Now eliminate column 1, row 1, and you're left with a 2x2 determinant. Minus, now do the same thing with the J. Why it's minus, you have to take linear algebra. Wait, you're taking it right now?
No, I'm taking it.
Okay, so you know why.
Yeah.
But you also have to take my word for it as minus, using cofactor expansion. Plus, now I do the same thing with the K hat. Two by two determinants are very easy. Times, minus, times. So just be 0 minus 0.
Doesn't matter if you do AD minus CB or BC.
It would be AB minus BC. But that is from the definition of a determinant. I'm just using the method. Because I don't think you actually put the definition of a determinant in linear algebra. They just go right to cofactor expansion and show you. And they use that as the definition, I believe, depending on the textbook. Yeah, I know. That's not the actual definition. I do the actual definition in my courses. It's fun. It has to do with partition, even and non-particle. It's fun. So I'm going to do it this way. Again, I'm going to write it out. That's I. It'll be 1 times 0 minus -2 times -2. That's J. And then plus 1 times 0 minus -3 times -2. K hat. And again, I'm going to write it in component form instead, but it's the same idea. 0 minus -4. And then what? -6. There's your cross products.
For the negative?
Because it's minus that -4, right?
No, okay.
Negative 2 times negative 2 is 4 minus, but then there's that minus down front.
Oh,
That is the method that they recommend, rather than memorizing the formula.
Okay.
But if you actually look at this method, go back to what the formula said, you see that it is this. Now you just need that magnitude, half of it, right? I'm going to do this, area of triangle PQR. I'll write it that way. It's 1/2 that magnitude. $16 and 36. 52. Is that right? 52 is 2 times, 26, but then that's also, so it's 4 times. 4 times 13. What's half of 4? That area, 2 to 13. I'm going to challenge you, actually. He should have been 132, not 123. So go ahead and just make that 132 on your own. Same problem. And see how much of a difference that actually made.
He would go to the next side. So,
Do I want to? No.
would you be able to?
That's like asking, do you want to go to work? No. Or we'll have an interview. Why do you want to work here? Because I need to pay my bills. They never actually want the honest answer.
So P should be
132.
Yeah, P is 132. Everything else is the same. And just see how much of a difference that makes. That's on your own. It's just a challenge. I'm not collecting it or anything. Unit vector perpendicular to the plane containing the vectors A and B. If we go back real quick, there is actually another property I think that wasn't mentioned. Yeah, why? Huh. Let's put that down. Guess what? I'm going to put it down now. So let's put it here. No. Property about correspondence. Just say W is the cross product of U and V, then W is orthogonal to both U and V. Which means this problem, we're just taking a cross product. And in general, it follows the right-hand rule, at least for the direction. So your fingers point out towards U, your first vector. They curl in the direction of your second vector. Your thumb points in the direction of the cross product. That's the right hand rule. Why is it the right hand rule? Why is it the left hand rule? Well, because back in the time when this was developed, it was actually considered to be a sin to be left-handed. They actually put people to death for that. Yeah, so everything, you always try to be right-handed. But, funny enough, left-handed is actually the dominant gene. If I remember correctly. Left-handedness is dominant. The right-handed gene is recessive. If I'm recalling that correctly. And then the ambidextrous people just speaks of nature. So the left-handed will just have to go the opposite, right? Point out, curl in, your thumb points in the opposite direction. So in this case, you'd be actually going downwards. So you have a vector perpendicular to the plane that contains those two vectors. Well, let's just draw an imaginary plane. And you have to remember that planes extend out infinitely. Two-dimensional sheets that extend in its two directions infinitely. So I'm just going to say that is a representation of our plane. And say there's vector A. For convenience, I'm going to put vector B at the same initial point. But remember, it doesn't matter. A vector perpendicular to the plane wouldn't have to be perpendicular to both A and B. I'm going to call it N. I'm going to call the plane pi. So N, and this is where we can use the term normal. N being normal to pi or perpendicular to pi means that N has to be perpendicular to A and N has to be perpendicular to B. So just let N be the cross product. And we want a unit vector, so once we find that, we'll then normalize it. Again, I'll just set it up. And the order doesn't matter. Because the only thing that's going to change is what? The direction, right? So if we look at this, and it ought to be coming out at us, we're going in. And I say going in, but you have to imagine it's actually going out, but from behind the screen. Both are still perpendicular. So the order that you do this doesn't matter. I'm just doing A cross B. So we want that determined. Oh dear, that's not good. Make sure to keep it like that. Thank you. It's going to need. Go away, go behind it. I'm just going to jump right to component form. -6 times -1 is 6. -3 times 3 is -9. 6 minus -9. It's 15. Now here's what I do. Instead of going this way, because it's negative, I go this way and keep it positive. So -3 times 4 is -12. 2 times -1 is -2. -12 minus -2 is -10. Then we're going to get 2 times 3 is 6. -6 times 4 is -24. So it's 6 minus -24. Which is what? 6 minus -24. Positive 30.
Yeah. 'Cause it's negative.
There's your vector. Isn't there a common factor? What happens if you just get rid of the common factor? Does it change its direction? Which means it'd still be normal, right? So I'm going to transform this. To 3 -26 instead. It's just going to make normalizing it easier. Remember, normalizing it 1 over the magnitude of n times n. Nine, 4 is 13. What's 13 and 36? Is that 49? What's root 49? There's our normal. There's our unit normal. Or if you flip its direction, that would also be an acceptable answer.
So you can just completely get rid of the 5 that you factored out.
Because what happens? All that happens is it scales it down by a factor of 5, right? But it doesn't change its direction.
Just the magnitude.
So it's still going to be perpendicular.
Okay.
Right? Be the same thing like it's kind of what we're doing here. There's our vector, there's our normal vector, right?
Mhm.
Here's the scalar. We just got rid of it. Still normal, right?
Okay.
That's what we're doing. I mean, I could have also just factored out a 10 if I wanted to. You would be left with 1.5, -1, and 3. That still works. Again, it just kind of makes it a little bit more hideous in terms of the arithmetic and algebra. Good? Excellent. Now let's go back to that awful, awful looking problem. Okay. So let's get started. I'm not going to set up the matrix here. And again, I'm going to flip the order. So it wouldn't be B1C3 first, it would be B3C1 first. Because you're multiplying by a negative. There is your cross product, B cross C. The A2 times the third component of our cross product above. And I am going to take advantage of copy paste. Then the A3 times that, right? A3 times the first component. Minus A1 times that third component. Right? Then A1 times that. Minus A2 times that, right? Distribute everything out. Yeah, the first component expanded out. Second component expanded out. Third component. No, I don't think it's gonna fit on that slide, actually. Now we're gonna do what one of my professors lovingly called dark voodoo algebra. There are two things you're always allowed to do. You can multiply by 1, because it doesn't change the value, and you can add 0, it doesn't change the value. I am going to go ahead and add 0 to each of those 3 components. Also going to rearrange them. Notice, I think that should be a C2, right? No, it should be a C1. Or C3 rather. So why did I add this one? Oh, right, okay. So notice, should be a D3 then, yes. For the 2 positive terms, both of them have B1. Then it's A2C2, A3C3. What's missing? A1C1. So I'm going to add A1, B1, C1 in it. But then I have to take it out. Which is fine, right? If you look at the negative terms, they both have C1, A2, B2, A3, B3, which is again, it's missing the A1, B1. There's the first component. Didn't change anything because I just added 0. Using a similar argument, we're going to add the term A2B2C2 into the second component, and then A3B3C3 into the third component. There's our vector right now. And the whole reason for doing that again, I'm only going to use the first component, but it's going to be similar arguments. First three terms factor out the B1. Second three terms factor out the C1. And actually, it's going to be a negative C1 that I'm factoring out. It's going to be B2 and negative C2 for the second. And a B3, C3 from the third. Oh, that's two different vectors. That's a sum of two vectors. It kind of makes it nice that I wrote it this way. Because here's your first vector. Here's your second vector. Oh. Well, notice the first vector has a common factor, a common scalar. The second vector has another common scalar. Oh, wait a minute. Uh-oh. All those B's in the first one should be C's. That's vector B, right? That's vector C. What's this?
The vector.
That's not vector A. Remember, that's not a vector, is it?
Sorry,
That's a scalar, right?
Can we do the same thing that we do earlier?
You don't need to. What is that?
Oh, determinant?
Not a term. A1 times C1 plus A2 times C2 plus A3 times C3. What is that? What's A1, A2, A3? Isn't that vector A? What's C1, C2, C3? Not A times C. Be more specific.
E cross C.
Cross product gives you a vector. It's A dot C. Okay. What's that? What's A1, B1 plus A2, B2 plus A3, B3?
B.
Wasn't that what we wanted? So it's complete. I think I actually have to add in the problem that A, B, and C have to be in R3. So I'm not sure if this necessarily holds in R4 or higher. It might. I'm just not 100% sure. I don't know how you go about the general proof, if it is true. Any questions on the cross product? So here's what I'm thinking. First 25 minutes of next class is the worksheet instead of 30. I can probably extend that, but then you get a 5-minute break. So we let out early now. Get 30 minutes to start class to do the worksheet, 5-minute break. Then we move on to the next subject, I think is lines and planes. And that's going to be the whole thing, right? You actually have 2 worksheets in this class. You're going to do the cross product, that's how we're going to start, and then 70 minutes of lines and planes, and the last 30 minutes of class will be the worksheet for that one. That's on Monday. Right? That also means that your first quiz will be Monday. You're going to go up Monday after class and you do Wednesday before class. I have it set up so that the quizzes will be every class we end with the 100-minute period, that's a quiz.
Are those also on the website, or they be?
No, it's gonna Blackboard.
That's on Blackboard.
Okay.
I already have it set to post.
And is it like honor locker, all that stuff?
I hate on and off. Recent Supreme Court ruling also dictated that the mandatory use of honor lock is a violation of the Constitution. Specifically, it's a violation of the Privacy Act. It's an invasion of privacy. Undue search and seizure.
Have you guys used it before?
No, NJIT we have like lockdown browser, which is worse than honor lock because I had to take an exam for econ here, and I don't know if you guys are aware that NJ Transit strike a few weeks ago.
Oh, yeah.
I had finals during that day, and basically our professor was like, listen, there's only 5 kids in this class. It was a CS class of 5 kids. I don't know why they couldn't. And he was like, listen, you just do it online. And like, for some reason, all the other kids just like weren't able to get scheduled. So I was the only one taking the exam on Friday at the regular time. So he was like, yeah, honor lock, I don't like lockdown browsers, so I'm just gonna have you just like do a 360 of your room and tell me what's in your room.
Yeah, so honor lock, you gotta do that,
Yeah.
and then.
And that's actually unconstitutional. You're not allowed to actually do that without a warrant.
Yeah, so I don't know.
So it violates the privacy
gave, gave our professors like a tour of our room and stuff.
It violates it violates the search and seizure clause of the Constitution. A warrant isn't necessary for that. That's what the Supreme Court ruled, and I agree with it, 100% agree with it. Also, if you're very astute, you were looking on Blackboard of the holiday, the first group assignment also went up, but it's not going to be due until the 30th of June. But it is up there, and it's designed to be challenging, because it is a group assignment. So it is going to be more challenging than the homework, and probably more challenging than the problems we're doing in class.
The details of it are on Blackboard. Okay.
And I didn't put it, let's put it here. And the quiz is only going to cover up to what we do on Monday. Fortunately, the way it's up, that also means that you're going to have a quiz just before the exam. Because the last 100 minutes, if you look in the schedule, will be a review. It's actually going to be, I'm thinking of making an extra credit opportunity, we'll see.
I'm guessing the quiz isn't timed.
It will be 90 minutes, but it's only 30 points. And that also would lose time to upload. So I would probably work it to be that you're only working on the quiz for 60 minutes and save yourself 30 minutes to work out getting all the files uploaded.
If you're the accommodations for
It's already set up in there. I should have it already set up. After class, I'll double check that for you
Okay.
and make sure that it is set up. I believe I put the accommodation in for both of the courses, but I'll just double check that. So that'll be next class. I'm thinking of one of 2 things. I might actually do this. Have a review worksheet in class just before exam 1, and then as a extra credit opportunity, make you use AI to generate a review of the topics along with solutions, and then your job will be to go through the solutions and point out any errors, which also serves as a good review. Just maybe one of those 2. That's what I'm leaning towards. Get get you used to working with AI and also reviewing the topics to make sure that AI knows what it's doing.
I forget, for like the submission of like our work for the quiz, you were the professor that specifically asked it has to be in separate files or on?
For what?
Like when we're submitting our work for.
Yes, like each question is.
Oh, for the quiz, yeah. It has to be each question, you only upload the work for that question.
So we'll do.
But it is a mixture of question types, so not all of them is gonna require an upload. There's some fill in the blank, some enter a number, numeric response, some multiple choice. I don't think this one has matching. Differential equations does. Right, but it's gonna be a mixture of types. Only the file uploads get partial credit. Everything else is all or nothing.
No, of course, that makes sense.
Okay. And just like that, for two of you, the weekend. The other two of you, I'll see you tomorrow. I mean, you don't have to show up. I don't care. We're just gonna be continuing the definitions of,
Yeah, not show up to class, right?
it's not like we're that far into the semester where you're gonna miss a whole lot.
Yeah, you live with two Irish Catholic parents.
I live with a 4-year-old and a 3-year-old.
Right. Yeah, see, I mean, they wouldn't carry me.
So the five of us the same.
They wouldn't carry me to